Okay, if it's all right, I'd like to go ahead and start the meeting. Welcome, everyone. I'll introduce myself in just a second. Wanted to, just a quick reminder about the couple bullet points on the screen right now. I want you to know that we are recording this meeting. Our hopes is to use the recording, edit it, and create a video that we can make available to people to view at their leisure to learn about these crop ET reports. We ask that you would keep your mic muted. The group, I think, will be large enough that we don't want to risk somebody's mic getting on or some background noise that can be distraction. And then because of having to mute our mics, we'll rely on using the chat box to ask questions. I'd like to say thank you to the program support unit at UC A&R in Davis, Quinn Zhu, Sherry Cooper, and other staff for helping me learn how to do this. And I also want to acknowledge Catherine Jarvis Sheen is also hosting this, and she will be helping manage our chat and as questions occur, and she'll be kind of keeping me on track subject matter wise if questions come up and stuff. Also, I'd like to say hello to Luke Milliron. He's on the meeting today and will be involved in the chat side. So with that, go ahead and get started here. I should say this is a first time experience for me myself with the chat or with the virtual meeting, and we're also as a unit kind of experimenting the first time. Okay, all right. So yeah, I'm Allan Fulton. I'm Irrigation and Water Resources Advisor. I try to serve Tehama, Glenn, Colusa, and Shasta counties, and I work out of the Red Bluff office that is now new to me as my living room. So anyway, looking forward to having this discussion with you, and I hope you find it helpful. So to begin with, this idea for this meeting kind of came about as a result of a survey that we did over this last winter, led by Catherine Jarvis Sheen and Kit Alves. This is one survey slide of 64 respondents who indicate they have used our crop ET reports in the past, would consider themselves frequent users. And so we kind of decided we would use this response to help guide what we talk about today and how we approach this. So you can see the purple bars and the green bars represent folks that indicate that they find these reports helpful to somewhat helpful. And you can also see of the 64 respondents here that when you add up those two bars, approximately 2/3 or more of the respondents are indicating they'd like information on pretty much all aspects of these reports to help better understand them and to help apply them and get more use and value from them. So with that in mind, today for this hour, my goal is one, to discuss the ET concepts. Indications are this has a lot to do in developing confidence in the numbers or deciding they're not for you. We'll spend a share of time about how to read the report tables, because there is a lot of information that we're trying to cram into a one-page table that we disseminate on a weekly basis. Part of reading the table involves picking an irrigation efficiency factor. We'll talk about the thought process of what factor you would pick, or if you want to pick one at all. We will try to address some common questions we get about these reports. One of them being, why do we report the ET in terms of inches per acre and not gallons per tree or per vine? And we'll discuss this and offer some tools to help with that. We'll start to then kind of dig into how to use this information, to begin to calculate irrigation run set time. And today we will limit the discussion to calculating the set time in relation to your irrigation system design. And because we think we want to be able to work through this at a comfortable pace, give people a chance to ask questions through chat, give you a chance to work through, to actually exercise a few of the pieces of information and do some calculations. We don't think that we can cover all that we'd like in one tutorial. So we are open to scheduling a second tutorial if you all indicate it would be worthwhile. And at the end of this, I will kind of highlight what might be some subject matter for a second or even third tutorial. So at this point, we'll spend a little bit of time on talking about crop ET concepts. I think many of us that are on this meeting are probably familiar with the general concepts. You may have seen the cartoon on the left before. Essentially what these reports are reporting, we send them out on a weekly basis. We're trying to make a weather-based estimate of the crop ET. That is the water that is leaving your farm field, whether it be an orchard or other crops, that's leaving it in the form of evaporation or transpiration through the plant. It is a part, this is called evapotranspiration, and it's we refer to it by the abbreviation ET, and it is part of conducting a water balance or a water budget. We're essentially tracking or trying to estimate accurately the amount of water leaving and comparing it to the amount of water coming in, either as precipitation or irrigation. Crop evapotranspiration is not something that we can see. We can feel it in the form of humidity, and we know it's happening as the soil dries out and as our crops show stress. The picture on the right tries to give you a bit more of an image of what is really happening in a field or in an orchard. And the point of this picture on the right is that ET is coming from the entire surface of the field, not only the trees, but the middles that may vary in how much water they use depending on how you manage your orchard floors and whether you use cover crops. So researchers, we try to actually measure the ET, and we use different tools to do this, to quantify it. And this slide shows you one technique. It's referred to as weighing lysimeters. The picture on the left is showing a weighing lysimeter being constructed. It's essentially a giant flower pot that's being put in a field. That box is filled with soil, and it's being set on a weighing scale at the bottom of that box. And to the picture to the right shows an almond tree planted in a lysimeter. I'm not thinking that's quite the same lysimeter, but they're the same style of lysimeter. Essentially we measure the evapotranspiration leaving that orchard or beneath that tree and through that tree by simply weighing the loss of water on a daily high frequency basis. So that's one technique for measuring ET. The lysimeter methods are, they're few and far in between around the world. They're expensive, and they are now not the modern way of measuring ET, although they're still used. We now are turning to thermodynamic methods, something called a residual energy balance, where we can set weather sensors out above the tops of the orchard canopy. You can see on the left of this picture, we have a bunch of weather sensors set up on a short scaffolding. Using my mouse here. This is a solar net radiation sensor. Where'd my mouse go? Okay. This is a sonic anemometer. This measures the temperature and wind speed of the air. Over here is a thermocouple. It too is measuring the temperature and the incoming moving air. Then below we have soil sensors that are buried that you cannot see that measure the heat that's being absorbed by the soil or released by the soil. And so we use these sensors to measure the incoming energy that drives the evapotranspiration. We measure the sensible heat flux using these devices. This is the wind that's moving warm and cool air in and out constantly, some more on some days than others, or more rapidly depending on how windy it is. And then this component is the heat exchange. What we're measuring is the latent heat of evaporation, or the leftover heat that is left to convert water to water vapor, either from the soil surface or through these little trees right here. And so this is kind of another technique that researchers use. Like rainfall, crop ET is reported in inches or millimeters of depth. Now, this is a fairly simple backyard rain gauge, but I thought it did a nice job of demonstrating the point that we measure rainfall in ET in terms of a depth of water. Oops, wrong button. So as I already said, ET is water or moisture leaving the field instead of incoming, opposite of rainfall. When we report ET, the measurement area is often an unspoken unit, but in the United States, that unit is acres. So we're measuring ET in inches lost per acre. If we lived in Europe or somewhere else that uses a metric system, it would be millimeters lost in per hectare. When we are measuring ET, we can measure it in different and report it in different time steps, ranging from hourly, daily, weekly, monthly, seasonally, or annually. For irrigation management, weekly time steps or more frequent time steps are most useful. Measuring crop ET is getting easier than it used to be and more affordable, but while it can be done on farm, it's my observation that most farms are not yet measuring ET in their orchards. So the picture on the left is a scaffolding system of where we put the sensors that I showed you earlier in the prune orchard, put them above a tall walnut canopy. To do the thermodynamic method that we showed. The picture on the right is a commercial sensor that is now available. This one is called Thule technology. There's also at least one other that I'm aware of. Arable Labs has a product. There may be others that I don't know of. This unit on the right, it has a small thermocouple sensor at the top of that pole above that little solar panel. You might be able to see it in this slide. And it's measuring that change in ambient air on a very high frequency. It's doing pretty much the same thing that I showed you in the picture with the small prunes. They also use satellite measurements of solar radiation, and they are doing that same thermodynamic process of estimating real-time ET in sites in specific orchards. The place this has been most adopted so far is in wine grapes in the Napa Valley area in the Rolling Hills country with a lot of microclimates that it's hard to place a regional weather station. Since 1982, the California Irrigation Management Information System, called CIMIS, has provided real-time regional measurements of short grass reference ET. It's abbreviated as ET sub O. I usually just say ETO. These CIMIS weather stations also measure rainfall. So the weather stations, they are standardized. They are placed in irrigated grass pastures with no obstructions of the wind or shading, things that would give you a false condition. All the stations use the same suite of weather sensors, and they're maintained consistently by the staff of the California Department of Water Resources. All stations measure hourly weather conditions and calculate the short grass reference evapotranspiration, ETO. Based on that hourly weather, and they also collect, measure rainfall hourly. This hourly weather data is then used to calculate the grass reference ETO, and it is founded on decades of research in California and worldwide. It uses a model called the Penman-Monteith equation. This is publicly accessible online data that's free to us to use. So there are over 150 CIMIS stations statewide. I've showed you in the last couple pictures, you can see that a typical CIMIS station on the left, measuring wind, solar radiation, relative humidity, vapor pressure, deficit, rainfall, a number of different things go into this model. The picture on the right shows you the general location of all the CIMIS stations throughout the state. And I placed the red box on that map. There are 8 weather stations that we target for our weekly crop ET reports up and down the Sacramento Valley. So what grass reference ET does and doesn't tell us? It does tell us the real-time measure of crop water use for irrigated pasture. As I said earlier, it's a standardized measure of evaporative demand for a specific farming region where that weather station has been placed to represent. It indicates to us the seasonal changes in evaporative demand. And it gives us a good sense of how normal or unusual the recent weather has been and how it affects evaporative demand. These grass reference stations, what they do not tell us is it does not give us precise estimates of crop water use for all other crops grown within that same farming region. And as I kind of pointed out with the Napa Valley wine growing country area, these regional weather stations may not represent unique microclimates such as some of our growing areas up next to the foothills. So how do we use this grass reference ET from CIMIS to create these tables that we send out to you? This is dependent on research that is conducted largely by the University of California, but also some other entities, USDA, ARS, where we research representative crop coefficients for each crop that is growing, that is of interest to us in our region. And a crop coefficient is simply a ratio of the ET actually measured in a crop, like I showed you with the lysimeter, or like I showed you with the residual energy balance techniques. So the actual ET measured in a specific crop divided by the grass reference ET for the nearest CIMIS regional weather station for that same measurement period of time. So again, it's just a ratio of the actual crop ET divided by the measure of the short grass reference crop ET. This slide provides some examples of monthly crop coefficients that have been developed by different researchers through the University of California. On the left, you see what we consider the almond crop coefficients that we're using for this weekly report. What this is telling us is that during the month of January, February, December, the ET coming out of a dormant orchard is much lower, only 40% thereabouts of a irrigated grass pasture. Then what it shows us in the almonds beginning in March, as the trees bloom and leaf out, you can see this crop coefficient starts to inch up, increase as the tree develops its canopy. And it shows us by June, July, August that those almond trees are using between 5 and 11% more water on an average daily basis than a irrigated grass pasture. We can move over to walnut. You can see you get a different set of coefficients. Walnut has a longer dormancy period than almond. That's why you don't see data in January, February, March, and December. Our principal variety, Chandler, leaves out April 1st. And you can kind of see how how that crop coefficient changes as the tree grows and develops. Here you can see that the walnut ET is much more similar to grass pasture, at least in the June, July months of summer, only 3 or 4% on average higher than pasture. On the right is prunes crop coefficient. Its season is not as long as almonds, but longer than walnuts. And you can see, typically these are smaller trees. You can see the crop coefficient doesn't ever quite reach 1, meaning that typically we see that prunes use less water than an irrigated pasture. So these are the kinds of crop coefficients that we use. We don't use the monthly value. We interpolate the weekly value in between for each of the reports. Actually, we use a daily value and sum it for the week. So this picture I like to use to give you a little idea of what we mean, what the crop coefficient is doing. It's basically trying to model what the canopy differences look like. This is a walnut orchard. In the upper left-hand corner is a later April condition. The trees, this picture doesn't show it too well, but the trees have broken dormancy, starting to get little leaves. And you can see the grass floor pasture in the middle is still green and growing. And in this instance, that's an approximate crop coefficient of 0.74. Picture upper picture to the right, you can see a crop coefficient of 0.96 by about 3 weeks later in mid-May, a lot of change in the canopy. And then lower left picture, we're kind of now getting more midsummer conditions. Canopy's kind of maxing out. See the crop coefficient is over 1 at 1.04. And then the crop coefficient in the lower right is representing 0.6. This walnut orchard, you can see that the trees have been through harvest. They're aging, they've got some wear and tear. And while you still have a denser canopy than you do in the spring, the crop coefficient is not as high because the leaves are older and are not as effective. So that's how we try to make the bridge between using the grass reference, giving us based on real-time weather, how we use this in the reports, real-time weather for the past 7 days. And then we use the crop coefficient to make the bridge to other crops. So now we're going to take a minute and kind of a stop, let you think. Okay, so 94% ETO represents a grass transpiration and soil evaporation. 94% a crop coefficient is a research-based multiplier to convert ETO to ETC for a specific crop. And then 100% ETC represents an estimate of water use by a particular crop. Yeah, looks good. So we will keep moving along here.
All right, Alan, before we move on, we had a question in the chat box for irrigated lands regulatory program growers who need to include ETO on their irrigation and nitrogen management plans. How do you do that for trees that are younger than fifth leaf?
Okay, so
Table that until the end of the discussion, or up to you.
yeah, I'll just say this. That's a real good question. This is actually a topic that we would propose for another tutorial if we could do that. These numbers will be an overestimate of trees younger than 5 years old. We can offer some ways to adjust, but that would be for another time. Okay, let me see if I can. Okay, so we'll start now focusing on what is in the weekly crop ET report. And it's our goal to apply the scientific ET concepts in a practical, informative manner for agricultural water managers of California. So in other words, it's always been our goal to try to package that whole process, that whole research discussion that I just went through. Our whole goal was to package that, summarize it, and maintain it in as accurate form as we could, so that a grower or a water manager would not have to tackle all those steps. Okay. So we provide these weekly reports. It's a team effort by our UC farm advisors and scientists from the California Department of Water Resources. As I already showed you, we access the real-time ET data and select the best available crop coefficients to estimate ET for the major crops grown in our area. The reports target specific agricultural regions, such as the northern Sacramento Valley versus the southern Sacramento Valley versus the northern San Joaquin Valley. Each week we provide estimates of crop water use for the past 7 days, a running total for the growing season, and an estimate for the next 7 days. We also keep a weekly and cumulative account of the amount of rainfall and provide that so it can be compared to the crop ET. I wanted to touch for a minute why focus reports on orchard and vineyard crops and not agronomic and vegetable crops. As you look at our list that we send out, it starts with that our major economic crops are perennial trees and vines. These crops are primarily irrigated with drip and micro irrigation methods, which enable more precision with applied water and make irrigation scheduling more valuable. Irrigation scheduling in forage crops like alfalfa are often dictated by cutting cycles. And we experience that there's not much room for consideration of ET. And then irrigation of vegetable and field crops often have a wide range in planting dates and length of growing seasons. Providing representative crop ET rates on a weekly basis is tricky in terms of just putting out information that represents things well. Okay, so we put out these ET reports in 2 forms. It's the same data, but 2 different report formats. This table that you are seeing here is an email format that I send out. It targets the northern Sacramento Valley. You can see, to get familiar with this table, essentially there's a top table and a bottom table. The top table represents, you can see the list of crops, starting with the pasture ETO and moving through. And what we have here are 4 CIMIS weather stations represented in the counties and closest town where they are located, okay? And then you can see that we provide the 7-day period that we are reporting for at the top of the table. You can see that we give the past 7 days or 1 week of water use based on the real-time weather. We keep a running total of the ET being used from the dates specified in these parentheses. These dates can change on some years, like last year was an extraordinarily late year. And for those that we don't specify a date, like olive, citrus, because they're evergreen, we begin accumulating them with almonds. Usually that's the first deciduous orchard crop that leaves out. So, and then we do in addition to the past 7 days in cumulative, for each weather station, we do a next week's estimate. Now this is next week estimate right now is based on long-term averages. It is not a current weather forecast. That's another discussion for another time. The bottom table, essentially what you have here, we call this the ET with the efficiency adjustments. So what we've done here is we've taken the ET numbers that are presented on the 7-day past week up here, and we're adjusting them for irrigation efficiency, which we will talk about more. So here at a 70% efficiency for olive, it's suggesting 1 inch ET, whereas at no efficiency adjustment, it's suggesting 6,800 ET. So any questions about this table? I'll let you look at it for a minute, but again, top table, unadjusted ET estimates, bottom table, adjusted for irrigation efficiency for weather stations in the northern Sacramento Valley, past 7 days, cumulative running total, and next week's estimate. No questions, I'll continue. Same data, second report format is our online reports. You can access them anytime at the Sacramento Valley Orchard Source website. Here you can see, here's the northern Sacramento Valley report link. Here's the southern Sacramento Valley report link. You can see that we archive past year's reports, okay? And then we have ET calculators, which I will use later to demonstrate. This is an example of one of the reports. This is online. This is the Tehama County Gerber. If this were a live link, you'd scroll down and you would then be able to see the table for Butte County bigs. Okay. Just wanted to mention, if anybody's ever curious about what crop coefficients we're using when we calculate these numbers, it's implicit in the table. The pasture is the grass reference ET. In this case, I used prunes as an example. ET was estimated to be 0.57 for that previous week of March 20th through the 26th. And so over here's the math. The 0.57 inches of the actual crop ET, 0.89 of the reference crop ET, which equals divide the 0.57 by 0.89 equals a crop coefficient of 0.64. So if you ever have a question of what crop coefficients we're using, it is implicit in there. Okay. Any questions about those tables before I leave? Sounds like not. Okay. So a recap of how to read these reports. Select the weather station that represents where you farm the best. Decide where you prefer to use, whether you prefer to use unadjusted ETC estimates or ETC estimates adjusted for efficiency. In other words, the bottom table or top table. This choice will focus and simplify the use of these tables. Select the crop of interest. This may be more than one crop type. Note the past 7 days, cumulative, and the next 7 days of water use. Also note rainfall and cumulative rainfall amounts for comparison. With this information, you are ready to relate it to your irrigation system design in orchard, soil, and root zone characteristics to help make irrigation decisions. So I wanted to speak a little bit more about how to select an irrigation efficiency level. So this little cartoon on the right hand side kind of reminds us of the sources of inefficiency. It can be runoff of the field. It can be deep percolation below the root zone, which is not, in my experience, very common in the deep-rooted tree crops. And it can be related to irrigation uniformity or non-uniformity. By definition, Irrigation efficiency is defined as water applied beneficially in inches divided by the total water applied in inches multiplied by 100 to express it as a percentage. So irrigation, meeting the crop's water requirements so it produces well, is a beneficial use. So too is frost protection. So too is leaching for salt control. So there are other beneficial uses of water to consider. So I wanted to spend just a second on reviewing the irrigation system distribution uniformity concepts. So this picture here on the left, almond orchard, where the average depth of applied water in a 18-hour irrigation is 1.5 inches. It has a distribution uniformity of 90%. What this means is the average depth of water applied across this block is 1.5 inches. And the range or the variation from it is relatively small, only about 0.15 of an inch from the far ends, the areas closest to the pump to the areas furthest from the pump and pressurization. When we have a lower distribution uniformity, we get a lot more variability in our applied water from one end of the field to the other. In what we consider the high quarter, usually closer to where the system is pressurized. In this example, 70%, you got 2 inches of water. On the farthest points, furthest from where the water is pressurized, we have almost 1/2 the water being applied. So a 2x factor difference when you have a distribution uniformity of 70%. So this is important to grasp, because if you try to compensate, realizing this is getting more water than here, and you try to compensate with longer irrigation set times to make sure this gets enough water, it means implicitly that you're going to over irrigate on the upper ends, areas under better pressure. Irrigation efficiency, it affects your power bill. It impacts your nutrient distribution and uptake. It influences your orchard uniformity, and particularly in these areas that are getting irrigated, these areas that are getting irrigated more, so that these get enough, they're more subject to tree loss and root diseases, long-term damage to the orchard. And low distribution uniformity defeats the efforts to schedule irrigations better. So it defeats our efforts of trying to make use of these crop ET reports. Potential efficiencies, this table is provided by Extension Specialist Daniele Zaccaria. It's in UCANR publication 8571. What you can see here is that in general, a newer, well-maintained, well-designed micro-irrigation system should perform in the 85, 90%, even up towards 95% distribution uniformity. It's this jump in irrigation uniformity that has probably caused us to move on from solid set sprinklers and other methods of irrigation in our orchard crops over the years. So we're back to which table do you want to use, the top half or bottom half, when you're reading our weekly report? You could say, no, I don't want to use an efficiency level. So you'd be using the top report, half of the table. And when you do that, what you're saying is that you're assuming you can irrigate at 100% efficiency, but you kind of know that's physically not possible. But you don't think you're too far off from that. There's the consequences and offsets of just using the numbers in the top half of the table is this might cause you to err towards under irrigating some parts of the field in comparison to others. However, trees with deeper root systems, it's been my experience, they typically can access the stored winter soil moisture that we usually get and compensate, so there's not so much of a large consequence. The alternatives, you can focus on the bottom half of the table and pick your efficiency level, okay? And not use the top half of the table. And this is essentially saying you realize you can't irrigate at 100% efficiency and you want to adjust for that. You want to allow more irrigation time to make sure all areas of the field receive enough water. The possible benefits of this are prevent under irrigation and grow a more uniform crop. If irrigation efficiency is too low, adding extra water can lead to over irrigation in some areas of the field while you're trying to ensure all areas get enough. It's better to improve irrigation system uniformity than to overly compensate by applying too much extra water. So again, you have a choice for simplifying how you read this table. Focus on the top half, not adjusting for efficiency, or focusing on the bottom half and selecting an efficiency that best affects you. We want to do another poll. So as we look at that, we can see that if we thought we had a system that was performing at a pretty high efficiency, we could probably keep it simple and just stick with the top half of the table. And if we had systems that we thought we needed to adjust for efficiency, then we would want to look at the second table, give it priority. So looks like for the most part, we had pretty good consensus on that. Okay. Kat, any other questions related to that? Let's see here.
Oh, that's it right now.
So just a real quick recap on selecting an irrigation efficiency. It is acceptable not to pick an irrigation efficiency level when using these ET reports, meaning just use the top table. This is especially the case if you use reports along with crop water status or soil moisture monitoring. So some other kind of irrigation scheduling tool to back you up. If you just use that top table, just know that you might be erring on the side of under irrigation, which might be the least risky in terms of root health and tree loss in these perennial orchards. If you prefer to select an irrigation efficiency level, newer pressurized systems are likely to perform near their maximum potential. So if it was newer system, you'd probably pick towards that 90%. Pressurized systems with better filtration systems and maintenance schedules are likely to perform higher. Pressurized systems with inadequate filtration, maintenance, and older than 10 years are more likely to perform at efficiencies less than 75%. If you're unsure about your irrigation system's efficiency, an evaluation may be appropriate. Would remind you that we have a very good mobile irrigation lab available to help you get an evaluation. And if you are more inclined to do it yourself, you can refer to this publication on irrigation and nitrogen management.
Allan, before you move on, I had a question in the chat. Does shade canopy influence ETC?
The shade canopy,
I mean, I think essentially
edged or something.
Size of the canopy influence ETC.
Yeah, that's a good question. It will. What we did to try to evaluate that, we used walnut as the example, and we measured that using the thermodynamic technique, putting those sensors above the canopies. We had one orchard that was like 90% ground cover, many years old, and then we had another orchard that was coming into production for 70 to 90% ground cover, years 5, 6, 7, 8, 9, 10. And in that situation, the difference in ET was very small, like on the order of 5%. That's why in these tables, we're comfortable with using these reports for orchards that are fifth leaf or older. The differences aren't that big. We also think you get some compensation when you hedge or do something to let more light in, you may get more ground cover effects. And so they kind of offset each other. So there is a difference, but they're not big differences in things that we've been able to measure as large. Why not do away? Okay, so let's see. So now we're going to move into just this discussion of converting crop ET rates from inches to gallons per tree or vine. And so why the interest in reporting ET rates in gallons per tree or vine? It's pretty obvious. It's easy to relate to drip and micro sprinkler emission devices where water application is rated in gallons per hour or gallons per minute from individual drippers or individual sprinklers. So we get the question a lot about why not report these ET numbers in this way. But why not do away with them? We report in ET, the rate ET in inches and not gallons per tree or vine because the rate of ET will change depending upon the tree or vine spacing. We're also unable to report ET rates for the range of potential orchard and vineyard designs in a concise one-page report. And then ET reported in inches compares easily with the soil water holding capacity of your orchard soils and of the incoming rainfall as you're trying to conduct a water balance or budget to see if you're in balance. So we've kind of stuck to our guns on reporting our ET in inches per week, but we have tried to provide you some tools if you want to convert. We've tried to provide you some calculators on our orchard website. And so I show you the page here, and I show you a link to convert weekly ET estimates to gallons per tree. Here's what it looks like. I put in some data. 2 inches of ET in a week reported. Number of trees per acre, 114. The calculator does the math for you, and you can see that trees can use a lot of water in a week and on a daily basis. 476 gallons per tree per week, 68 gallons per tree per day. So the calculator is handy. I always like people to understand and be able to do the calculations themselves, know what the calculator is doing. So here's kind of the steps to convert. If there were one conversion factor, if I could challenge you all to memorize, it would be to memorize 27,150 or 154 gallons of water in an acre inch, okay? That's 1 acre covered with an inch deep water, 27,154 gallons. So if I have ET of 2 inches, I just multiply 2 times 27,154. I can get a bigger number, 54,308 gallons. And then we know that in this case, the orchard design was 114 trees per acre. You divide that by 114. That's your 476 gallons per tree per week. Divide it by 7 days. That's how you come to 68 gallons per tree per day. So we'll see if we have time to do this. We're going to have to be kind of quick here, but okay. So work with the information on this slide for a minute and see if you can make an estimate of what convert from the 1.5 inches per week water use to gallons per tree per day. We'll give it about 5 or 10 more seconds and wrap it up.
And then Allan, once you walk through the answer to that, I have another question.
Okay. So the answer is, as those who responded, 65 gallons per tree per day. I think I have a picture on the oh, I guess I didn't show the calculator on that one. Okay, so again, what you do here is 1.5 inches times the 27,154, which I don't have that number in front of me right now, but then divide it by 90, and that works out to be 65 gallons per tree per day.
You had to divide by 7 as well to get to.
Oh, and divide by 7. Thank you for reminding me. That was, I stopped at on a weekly basis. Thank you, Kat. Okay.
Okay, are you ready for that question, or did you have a little?
Yeah, sure.
Okay. This is another question related to how things in an individual orchard might affect the ETC. That's not. How does having ground cover such as sod affect ETC?
Okay. So we know ground cover can, generally it will increase the ETC, but it's very important as to what kind of ground cover and the season on which it grows, okay? Maximum research that I'm aware of would suggest that it could increase ET up to 25%, but not necessarily, okay? But that would be something you'd want to be cognizant about. If you had a distinct, what our measurements are for pretty typical methods involving mowing, just letting the resident vegetation grow, nothing planted, cultivated, or attempt to grow an additional cover. So if you were modifying your middle management quite a bit, you might want to add some other kind of irrigation scheduling tools in it, soil moisture monitoring or plant-based monitoring. Okay, so now we'll move on here to using the weekly crop ET reports. Oh, okay, struggling here. Okay, using weekly crop ET reports with your irrigation system information to guide irrigation decisions. So in order to actually apply the ET information and begin to get information that tells you how long to run the system or gives you insight on possibly how often, you have to have a reliable estimate of your water application rate of your system in order to relate the two together. So I'm going to show you here for a minute how to calculate your average water application rate if you don't know already. The alternative is to convert the ET estimates to gallons per tree and use what you know about your drip emitter or your micro sprinkler flow rates and go that route. And again, I'll just remind you that whenever you use these crop ET reports and you team it together with your irrigation system design information, the more uniform the system works, the better the information, the better the estimate you're going to get. So here's an example, do it yourself by hand calculation for average application rate. This is, I believe, possibly prune trees, 183 trees per acre, double line drip, half gallon per hour drippers. And there are, maybe I forgot to put the space in there, but there are 14 of them per tree. So they're 2 foot apart, 2 lines. And so when you do the math, 183 trees, that's 14 emitters by half gallon. So that makes 7 gallons per tree. That's 1,281 gallons applied per hour per acre. And then remembering that 27,154 gallon conversion factor, you divide the gallons delivered in an hour with that double line drip system by that factor. It points out that your average water application rate is just under 0.05 inches per hour, or 0.05. So on our website, we provide calculators to help you do this, a water application rate applicator for drip and micro sprinklers, and a water application rate applicator for mini sprinklers and solid sets. The reason there are 2 calculators here is that for this web platform, I had to keep the calculator pretty simple. And so the drip and micro sprinklers are rated in gallons per hour emission, half gallon per hour, 1 gallon per hour, 10 gallons per hour. And then the ones for application for mini sprinkler and solid set sprinklers, they're rated in flow of gallons per minute. And that's why there are two calculators. Here's an example of the calculator. Flow rate, this is the one that we just did. Half gallon drippers, 14 drippers per tree, 183 trees. You can see the answer, 0.047 inch per hour. Okay, I know we're getting short on time here. We're nearing the end. I'd like to ask you to think about what is the hourly rate of water application for this particular system.
And then Alan, once you walk through the answer to this, I have another question for you.
Okay. This one, I think I show the calculator afterwards. Okay, so we had 8 respondents. All 8 got the answer right, 0.056 inch per hour. So you would take the 180 trees. There's 1 sprinkler per tree. So you multiply the 180 by 8.5. That'll give you a number of something under like 1,600 gallon per hour. And then you divide that by 27,154, and that will give you the 0.056 inch per hour. Okay. This is using the calculator that's online to arrive at that number. Again, 0.056 inch per hour for that particular situation. Okay, so the last little piece, we start getting to...
Let me interject a question here
yeah.
before we move into that. Yeah. How does weekly crop ET information help to with the proposed groundwater management plans?
How does weekly crop ET information? Well, the idea would be 2 ways. One, if this information helps growers grow better crops, it could potentially improve the unit production per unit water. There's also the side of it that it could help avoid over irrigation that sometimes happens in the spring, and could actually point to some places where we could realize some water conservation. Okay. So the last little piece here. So another piece that we can use this information for is to calculate irrigation set times to replace weekly ETC. Now I've put in this little handwritten example on purpose because when we originally started disseminating these reports, we've been doing this for years. My goal was to simply help people make the connection between what the crop water use is or what our estimates are and make the connection with their irrigation system design. And my thought was, if nothing else, if each week a little reminder would cause people to just put pencil to paper, or even if it's on the back of an envelope, it would cause you to think about, do I know my water application rate? Do I have an idea of the ET rate, how it changes with seasons, how different things might affect it, weather, unusual weather? And so just a back of the envelope calculation. And so here what you see is you see the information that points out that the water application rate was 0.06 inch per hour, rounded up, and that for a particular week in July of 2019, the ET was just under 2 inches at 1.99. You take that ET, divide it by the water application rate, that suggests 33 hours of irrigation, okay? I wanted to point out that we have what I call a little simple calculator, a weekly irrigation scheduling tracker. It has no memory. You can't keep these things. You put information in, it just allows you to do a point in time check. And so here's that example run through that calculator. 1.99 inches ET, water application rate 0.06. Actual hours of irrigation water applied for the week, 24. And then it gives you an answer. The maximum hours is 33 hours. Clicking back to this handwritten example, 33 hours. This maximum, this is the maximum. The person reports putting in 24 hours or a depth of 1.4 inches or about 70% of the crop ET. It's just to kind of give you a relative frame of how you have irrigated versus what the crop might be using. Which leads to a conversation for a different day. If we were to talk about other soil and plant-based methods of irrigation scheduling to reinforce the use of this crop ET information, you might find that you don't have to irrigate this maximum hours. So the last knowledge check is one more problem for you. There should be another poll come up here.
Looks like we closed the poll.
Yeah, okay, I got it back.
Five folks answered correct. It was A. 26 hours maximum was needed. 69% has been supplied so far.
Yeah. Okay. And so, yeah, so in this case, it was partial irrigation, and this information would kind of provoke the thought, do I need to be irrigating more or is it adequate? And here's the example calculator with the particular information. So we're going to wrap up now. I'm sorry I went over about 10 minutes here. So what we've learned over time, there's a lot of questions about these reports. We tried to cover some of those today. I hope this helped. I'd like to propose a second tutorial. Here's some of the possible topics that we would try to cover. It might be a second and third tutorial, break it up so we have more time. Some of the possible topics would be using these weekly crop ET reports in young trees. How do you relate these ET reports to other soil and plant-based irrigation scheduling tools? Possibly discuss the idea of what's out there available in the way of irrigation scheduling digital tools. The university has what's called Crop Manage, might be an opportunity to introduce. And we could also revisit any of the previous topics as needed that we've talked about, such as maybe taking a deeper dive into irrigation system evaluation, and certainly could be open to having some other presenters involved. So, so I'd like to say thank you for your time today and ask you to consider this one last survey. Okay, so in general, we've had some favorable response. We will, I'm interested in providing more of these tutorials. We'll see if we can make some things happen in the next week or two. And again, just say thank you for joining us. And if you have any feedback, you can certainly contact any of the farm advisors directly. Thanks. Have a really nice weekend.
Thanks, everyone. Thanks for coming.
Thanks, folks.
We'll be
Bye.
following up over email with more information.
Okay, thanks.